How might our reality change, assuming it were true that time does not exist? Time could be one of the greatest deceptions in our science and all human culture. New evidence now shows that the reality in which we reside is very different. Time doesn't run forward or backward. This notable realization could change our perception of reality forever. Who doesn't know the feeling of looking at the clock in the morning and the time pressure that comes with it? We are late, early, or running out of time. In daily life, we experience stress because there is often not enough time, or time doesn't bring us what we would like. Scientists are now warning that we are making a huge mistake, one that separates us from the true experience of the world and damages our brain. What really is time? What do you think of as its essence? Is it a sequence of events, a subjective feeling, or a physical quantity? You may not be surprised to learn that science has a similar problem defining time as we do as ordinary individuals. It is precisely this fact that makes time so fascinating, the fact that time is elusive and, strictly speaking, cannot be proven. This also puts time as a quantity itself to the test. What if time doesn't exist? Science describes time as a fundamental physical quantity that is seen as a continuous, irreversible sequence of events. Albert Einstein's theory of relativity considers time to be relative and dependent on the movement of objects and people. Time also acts in relation to gravity. Time passes differently near massive objects than near lighter objects or in a vacuum. Time has become an essential part of our four-dimensional world. Space consists of three dimensions: length, height, and width. Within this space, things happen and objects move. In space, countless galaxies move, and within these galaxies, stars revolve around their planets and the galactic center. In this process, time seemingly passes. A star system takes a certain amount of time to orbit the center of the galaxy. Planets orbit their stars within a specific time. On planets, beings like us appear to exist, structuring their daily lives according to time. But is this subjective perception of time proof that it actually exists? Albert Einstein was not entirely sure throughout his life. He described time as one of the most uncertain quantities in the universe. He already speculated that time might be an illusion rather than a fixed physical quantity. Time dilation and the theory of relativity. Was Albert Einstein right? A space traveler could fly into space and return to Earth after a certain period. The phenomenon of time dilation would mean that time would pass differently for the astronaut in space than for people on Earth. Theoretically, this would mean that an astronaut could return after experiencing just a few years, while much more time had passed on Earth. The astronaut would have aged less in space and might not even recognize their old friends. That much is clear from the theory. However, too little is known about the future of time to confirm this effect fully. Additionally, we are currently unable to conduct long enough space missions to experience and scientifically investigate time dilation. Albert Einstein showed in his work that time depends on speed and gravity. In the special theory of relativity, time is observed to move more slowly for moving observers than for those at rest. This shows that time is not an absolute universal quantity. The clearly relative forces at work in space remain a mystery to science today. Relative means that these forces do not represent a definite and linear magnitude. The differences in the effect and behavior of these forces are clearly noticeable on Earth and in the nearby universe. We must assume that relative forces, such as time dilation and acceleration, have different effects elsewhere in space. This fact alone could explain certain ambiguities in the description of the universe. Quantum mechanics knows no time. Are you aware that your reality is composed of countless tiny particles, all of which behave very strangely? We perceive our world as solid, built from objects, habits, and our daily routines. In the morning, we wake up at roughly the same time, go about our responsibilities, and expect our coffee to stay in the cup. We also assume that we can place this cup on the table. But imagine that, in the quantum world, your coffee cup could also be an apple, and your table could vanish when you leave the room. This is exactly how quantum particles, tiny units of light that make up matter, behave. The behavior of these particles not only challenges our understanding of matter, but also of time. Quantum particles know no time. Just as they can exist in multiple distinct states simultaneously, they can also exist in multiple times at once, or perhaps they do not experience time at all. This would mean that time is an illusion tied to our experience of matter. But if we realize that matter and time could be illusions, then what is truly real? This question is fascinating and continues to occupy quantum researchers worldwide. Classical physics struggles with the discoveries of quantum mechanics, precisely because massive stars and galaxies are, At the quantum level, nothing more than fluctuations of light or optical illusions. Conservative scientists tend to reject the findings of quantum mechanics. Surprisingly, even the brilliant Albert Einstein was one of them. He discovered quanta and won a Nobel Prize for it, yet later became so frustrated with his own discovery that he firmly rejected quantum physics. Time emerges in the transition to matter. Strictly speaking, time may arise somewhere in the process of matter formation. Wave-like potential to the characterized molecule. Anyway, nobody has yet found this force. Unexpectedly, the circumstance is comparative with the moment at which matter emerges. Molecule specialists have been going after for quite a long time to experimentally depict the snapshot of the development of solid matter. However, up until this point, without progress. Particles acquire their mass in the Higgs field. The field is connected with the Higgs boson, the molecule that was first recognized in the molecule gas pedal in Geneva and which was consequently named the God molecule. Anyway, the God molecule has its trap since it acts so unusually that it's difficult to yet again make sense of how matter is made. Scientists are confronted with a secret. Is it maybe obvious that time and matter are very different from what we think? If time describes processes in matter, but matter does not exist and cannot be described, what might be said about time? We should assume that matter is simply a change that arises through our perception but isn't real. Then, time could also emerge only in our perception and not be real. Present-day savants such as Kurt Gödel have shown that time could be an illusion since it doesn't exist independently of space and matter. Gödel's work on the general theory of relativity showed that specific arrangements of Einstein's field equations could enable time travel, raising doubts about the linearity and truth of time. In a static four-dimensional universe, there is no progression of time. Some present-day scientific theories do hypothesize a universe wherein all events exist simultaneously and there is no linear stream of time. In this model, there is no past, present, or future, only a static whole. We travel as awareness through this so-called block universe, and apparently experience the progression of time. This would imply that our experience of time is directly linked to our human presence and the way our brains work. Theories like timescape cosmology or the cosmic voids hypothesis take up these approaches and suggest that time is possibly a local phenomenon shaped by the structure of the universe. This would support the assumption that time is a relative phenomenon within the universe. Yet, it is not a fixed and distinct quantity. It exists because we experience it. However, this doesn't mean that it is fixed or determined in the sense of scientific permanence. It means that time changes from a fundamental aspect to a temporary and inconsistent phenomenon that only exists under certain conditions, such as in human perception. If that is the case, we should credit less importance to time in general. Researchers should focus on areas such as investigating our experiences and brains. Is time affecting our minds? Obviously, scientists have also tried to locate the essence of time within our brains. In the brain, time primarily occurs in the so-called temporal lobe, which is situated at about the level of the temples, to the left and right of the forehead. When subjects are exposed to time-related stimuli, these areas of the brain react, and there is a change in the current flow and brain waves. When subjects are subjected to stress-related time stimuli, these areas are practically on fire. The temporal lobes experience extreme conditions under stress, which have an adverse effect on the rest of the brain. In an experiment, specialists found that only a few time-related stimuli did not put the brain under stress. Even just imagining always having enough time and no time pressure gave subjects a sense of relief. But why is that? Analysts argue in their work that the concept of time alone is so negatively intertwined in our minds that all stimuli related to time represent a potential for stress. So, does the illusion of time make us mentally unwell? And if time does not exist, what is reality? Imagine your reality as it is right now. Then, imagine that time simply does not exist. You probably have difficulty picturing that. That is how deeply our feelings and daily experiences are tied to time. Buddhist monks claim that the essence and limitations of time can be overcome through techniques such as meditation. In their view, time truly is just an illusion. Those who have transcended time recognize the eternity of all being and live in a dimension beyond a linear passage of time. The monks experience the changing of the seasons like others. They see the sun rising in the morning and setting in the evening, but they know that these events are neither absolute nor related to time or physical forces as we understand them. For them, time and matter are part of the Maya,
Liftoff
the illusion
of
of this
the
world.
Delta rocket carrying
Subscribe now
blast,
and never
a
miss
gamma ray
another video
telescope
again.
searching for